Alright, so we have some violet light. We're going to shine it onto a photoelectric surface. Has a certain work function, 2 electron volts. We want to calculate a few things. So the first thing is, let's calculate the energy. So we use our equation, E equals HF. Now I didn't give you the F, right? So what do we have to find first? Got to find the F, so V equals F lambda. Now you could combine these two equations, so instead of having to make 2 calculations, you can make 1. What would a derived energy equation look like here? HV over lambda, correct. So let's just do that, save ourselves a little bit of time. So H is 6.63 times 10 to the negative 34th times V. What's our V? 3 times 10 to the 8th. And what is our lambda? 10 to the negative 9th. So what do we get for energy? Help me out, guys.
4.97 times 10 to the negative
18?
19.
19 joules. Let's convert this to electron volts. So we will go, that's that many joules. Well, 1 joule, 1 electron volt is 1.6 times 10 to the negative 19 joules. So what do we get? About 3 point, or 2 point something? Or 3? 3.1 electron volts. Okay, 3.1 electron volts. Now there is another version of H that sometimes comes in handy, so I'll just give it to you right now. 4.14 times 10 to the negative 15th electron volt seconds. So sometimes if they want your answer in electron volts, or if it's useful to go to electron volts, you can use this version of H instead of the other one. Like, it would have been easier in this problem. Okay, how do we find the kinetic energy of the ejected electron? Well, this photon comes in at 3.1. The work function phi is 2. Therefore, what's the ejected electron going to have? The difference between those, right? 3.1 minus 2 leaves us with 1.1. So this would be the kinetic energy of the ejected electron. That was easy. So again, the concept is you just are going to subtract those two. Okay, how are we going to find the velocity? Well, this is a kinetic energy. What's our equation for Ke? 1/2 mv squared. Okay? Now this kinetic energy is based on which unit? Joules. So regardless of what you calculated here, you have to convert this to joules. You have to convert this to joules. Okay? So let's do that. So 1.1 eV times 1.6 times 10 to the negative 19 joules per electron volt gives me how much? 1.7? So you have to convert that to joules when you use your 1/2 mv squared equation. And by the way, if you forget to, that will be okay, because you will notice your velocity is faster than the speed of light, which means you did something wrong. So go back and fix it. Alright, anyone remember the mass of a single electron? Okay, so one a single electron is 9.11, 10 to the negative 31st. Let's calculate our velocity. Hopefully it's less than the speed of light. How fast you get? Did you say 10 to the 5th? Okay. One last question. What would happen if I sent, what would be the velocity of the ejected light if I sent a beam in at the work function? Same as the work function. It would be 0, right? This is when it just starts to eject, which means it would have essentially a velocity of 0. Anything greater than that would be faster.